to start with a new topic that is called gravitation. So let's start with a very common thing, what we know about the gravitation. So for us, the gravitation is very simple. It is the force that is being applied by the earth and the objects fall toward it. Very simple. Even in Newton noticed the same thing, that apple is falling on the ground and he inferred there is some force acting that pulling that apple downward. Even we have that apple, so we can just hold it here and we will allow it to fall and it will eventually fall downward instead of going anywhere else. And why this happening? Obviously, there is a gravitational force that acting downward. Now my question is very simple, that if the all objects falling downward means yes, it is the force, only force that is being applied by the earth. So obviously not. It is not that the force only applied by the earth. It is being applied by all the objects around on each other. Even you can see we have just took that same apple to the space, okay, and an astronaut trying to grab that apple. Okay, so is there any gravity working over there? So you can say that yeah, there is a gravity between that small apple and that astronaut, but there is no gravity of such a big mass like asteroids or some planets. Obviously not there. So why? And the big masses have the bigger gravitational pull, and they can pull the objects toward them. Here in space, the astronaut do not experiencing any kind of force. That why he is floating in the space. Even that apple is also floating over there. Okay, so if you can get this, yeah, there is a force between that astronaut and that apple. Okay, suppose that I have this astronaut and going toward each other. So, but this force is very small that cannot be even experienced by any of them. But there is a force that is smaller force. Okay, now, so as we come to the conclusion, there is some smaller force that acting between the astronaut and the apple. It's not just about the Earth. So in the final statement, what we can give, every object that has some mass exerts a gravitational force on each other object. Okay, anything, any smaller object that can apply the gravitational force. Very simple. Now this depend on the masses. The second line is very clear that the strength is dependent on the masses, not try to stand. As we say that everything that pulls each other. Okay. So now I just took this apple and this duster and holding it together. And these are not applying force anywhere. If I use my hand to make them closer, but it's not happening by itself. If it took two magnets, it will eventually pull it toward each other. But it's not happening with the gravitational force. No, there is no force. I cannot experience any force that it is pulling my both hand together and then it will struck like a magnet. No, it's not happening. Actually, there is a force, but these gravitational force are so weaker in between these two objects that they cannot pull each other. So everything is falling toward the earth and not attracting toward each other. And the very simple region, obviously these masses are very small, and the force that is being applied by the earth is very strong as compared to the force applying to each other. Means the downward force is greater as compared to this linear force, and they are not going anywhere together. Okay, because earth have the greater mass, the bigger mass of anything that we have on this planet, obviously. Yeah, so we do not have anything bigger as compared to earth, obviously. So earth have the bigger mass and the bigger force. Okay, that the force is directly proportional to the mass. Okay, here we can say that here that the force equals to mass into acceleration from the Newton's second law. We are trying to understand this, how this happening. Okay, so acceleration is inversely proportional to the mass. Means greater the mass, smaller will be the acceleration. very inversely proportional since the force is constant. All the force apply equal and opposite force toward each other, but it is dependent on the mass they have. Therefore, Earth has the greater mass and have the greater force, and no other thing that can pull the objects toward each with that greater force. Yeah, someday if such big planet come nearby the Earth, okay, so maybe that gravitational pull will be more than the Earth, then we can move from this planet to other planet because of their gravitational pull. You must have heard about the tides, okay, due to the moon's gravity, tides in the seas that is due to the moon's gravity. Even we have such a big thing that on the planet, three George Dam built in the province of Hubei in China, and that is that big enough that it is affecting the rotation of Earth. Even it had changed the poles that we have the North Pole and the South Pole. It had changed a little bit, very small change that it can take, but it had done that because it's such a big um, thing or big object that had been created on the Earth. Okay, now, so why do humans do not attract each other due to the gravitation? Obviously, that the force being applied by the Earth is very less as compared to the force applied by each other. That's why they are not attracting each other. And that it's very good that if we're not attracting anything anywhere, because if we go anywhere and my apple is sticking to me, my dust is sticking to me because I'm a bigger mass. But thankfully, we have the earth that attracting all the things downward and keeping these things on their place. Otherwise, everything will be stuck to us, and someday we will stuck to the building because building is a bigger mass. So, the thing that can happen. Okay, so we are not going to deepen in this. Let's move forward. Okay, so what we have this gravitational definition. That definition is we will look at the proof in the next section. Okay, the gravitational force is the attractive force between any two objects with non-zero mass and separated by the distance. So as you can see, there are two objects of mass m1 and mass m2. Either of them can be bigger. It doesn't matter. Okay, and they have them some separation of r, and we have the formula that is g m1 into m2 by r square. And this g is the gravitational constant, and that has been derived by the Newton itself. Okay, himself. Sorry. So Newton had discovered this g, and that is the universal gravitational constant, and that need to be used even you are working with the planetary motion or even you are working with the very smaller objects. Okay, it is applicable everywhere throughout the universe. Okay, so that's why we call it as the universal gravitational law. Every object of the mass in the universe attract each other of the mass with a force which is directly proportional to the product of their masses and inversely proportional to the separation between them. As we just saw, this is directly proportional to the mass m1 and mass m2 and inversely proportional to the square distance between them, square of distance between them. Okay, so why inversal? Because very simple that we are just said, because it is applicable throughout the universe, whether they are bodies are small or whether they are bigger. Okay, so now we have a small derivation that we can do it fraction of seconds. That let's take the two masses of mass m1 and mass m2, and as we have just seen that these masses are directly proportional to the force applied on it, that therefore F is equals to directly proportional to m1 and m2, and they are inversely proportional to the separation between them, square of the separation between the inverse square law. They follow the inverse square law. It is stated as inverse square law because it has inversely proportional to the square of its distance. That's why we call it inverse square law. Combining these two equations, we will get obviously this equation, and removing this proportionality sign with the proportionality constant that we call at g. Okay, and this is g gravitational constant. So hope you have understood many new things, and I've tried to create a new understanding for this. So hope you understand. That's all for the today, and see you in the next lecture. Till then, take care. Bye bye. Signing off.